Dot product. We've talked about how to add two vectors. Is there a way to multiply two vectors? Well, one way is referred to as the dot product, and this is a way to multiply two vectors but end with a scalar. In other words, the answer to the multiplication problem is just a number. Here's the definition. Let's say vector A is a1i plus a2j, vector B is b1i plus b2j. Then the dot product of vectors A and B is found by multiplying the horizontal components together, multiplying the vertical components together, and adding up the results. Again, the answer here is just a number. It turns out that the dot product shows up in some important calculations. Let's look at a simple example. So I've got vector A is 2i plus j, vector B negative 3i plus 2j. I want to find the dot product of the two vectors. Well, according to the formula, all you do is you multiply together the two horizontal components, the a1 and the b1, and then you add to that the product of the vertical components, which would be the 1 that's in front of this j right here, and the 2 that's in front of the other j. Work out that calculation and you're done. I'm going to get negative 6 plus 2, which is negative 4. Again, the answer to the dot product is just a number. Now, an interesting thing happens when you dot a vector with itself. So I'm being asked here, find the dot product of A dot A. Well, I would do the same thing. I would multiply the two horizontal components together. That would be 2 and 2. And then 1 and 1 for the two vertical components. And this comes out to be 5. And you say, well, why is that interesting? Well, take a look at the magnitude of vector A. We have a formula for that, don't we? The magnitude is the square root of the horizontal component squared plus the vertical component squared. And when I work that out, I get square root of 5. You can see that essentially similar calculations were done. Here's the 2 squared, here's the 1 squared. The only difference is with the magnitude, I ended up with the square root of 5 instead of just 5. What we've just learned, though, is apparently when you dot a vector with itself, you end up with the magnitude of the vector squared. If I square that square root of 5, of course, I'll get 5. And so this becomes, again, a useful piece of information as we continue on in our study of vectors. Thanks for watching.